Okay, this first video is for 5.5 day 1. It is the factoring of polynomials. I'm going to show the sum of cubes, the difference of squares, which has a difference of cubes and a sum of cubes in it, mainly the difference between the two types of problems, and then some factor by grouping, and then some quartics, which is up to the fourth. So the first thing I have is problem number 21, 64x to the fourth plus xy cubed. The first thing you want to ask yourself is, do you have a greatest common factor? So my greatest common factor that I'm going to pull out of both sets is an x. So an x on the outside. And then this problem with that part there is 64x cubed plus y cubed here. So the next step is saying this is the sum of perfect cubes, possibly. I know x cubed is a perfect cube, y cubed is a perfect cube, but is 64 a perfect cube? Is there some number times itself 3 times to get you 64? If you don't know them, he just wants to make, you just want to make sure that you go through and say 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So I know that 4 cubed is 64. So as an A and a B, what I'm looking at is A. Pen is not alive. Hold on. Let's get my pen alive. So A, that pen just doesn't want to play nice, so we won't use it. Let's try my black pen. A cubed, and then B cubed. So what cubed gets you the 64? So really what you're looking at is you want to break it down into this. And then that symbol in the middle, that plus sign, just doesn't change. So what cubed gets you 64x cubed, and what cubed gets you y cubed? So this first part would be y cubed. We'll see if that pen stays alive for this whole thing. And then 64 would be 4x cubed. And then this is plus. And then this is on the outside still with the x. Okay? So what you're going to do is you are then going to take the 4x and the y, and you're going to plug it into the formula that was given in your guys' notes. But I'm going to write out the set in stone part. So you have your first set of parentheses and you have your second set. Because this is a plus, this first one's a plus. Then you go minus plus. Okay? This x is still on the outside. And then all I'm going to do is plug in my a's and my b's. So this first part, which is x squared, or excuse me, 4x, that's your a. And this is your b. Okay? This next part, let's see, there we go. I know it's not going to be as bright, but it shows up a lot better. So what I'm going to do next is I'm going to take 4x squared. So 4 squared is 16, x squared, y squared, and then this middle term is going to be those two combined together. And I'm going to write it in purple because of the fact that my green is not working and it's making me mad. So 4x times y is 4xy. Now I'm done factoring. That's it. Done. I follow the formula that was provided in your guys' notes. And this is what is your factored form. This here cannot be factored to something that you guys are able to do. This could be factored possibly to a cubic, depending on the type of problem that you have. Now, this next problem, you can do by cubes or you can do by squares. I'm going to do by difference of squares. Why am I going to do by difference of squares? Well, let me show you. Common term in both of these is a squared, so I'm going to pull an a squared out. So I have a squared times a to the 6 minus b to the 6. Now, when you have a difference, you can do difference of cubes, or you can do the difference of squares. I'm going to do the difference of squares because that's going to factor out better. Always do difference of squares if possible. How do you know you can do difference of squares? Well, what you're asking yourself is, what squared gets you the first part, and then what squared gets you the second part? That's the difference of squares. Kind of the same thing as cubes, it's just you factor differently. So a cubed gets me a to the 6, and b cubed gets me b to the 6. Okay? So what I'm going to do is the form of factoring for a difference of squares is you have a minus and you have a plus, because that's the only way things to cancel out. And then what you do is you just put these in the respective spots. So a cubed, b cubed, b cubed. Now that a squared is still out in front, I'm just going to keep bringing it down. So now looking at this, I have a difference of cubes, and I have the sum of cubes. So I'm going to break each one of these down. Now, these are in the general form where you can already see what cubed gets you. What a value cubed gets you, the total of a cubed. But if you don't see it in both of these, this is a, and this is b. Okay? A and b respectively is your first part of your first term, and your b respectively is your second term. It's just a generic way of saying AB. In this case, it's the same thing. So, the first one is subtraction, factors out to b, parentheses, parentheses, and then addition. So this is subtraction, plus, plus, addition, subtraction, plus, and then respectively, based on cubic, this would be a, this would be a squared, this would be b, this would be b squared, and in the middle it's a times b. This would be a, this would be b, this would be b squared, this would be a squared, and once again this is ab. Now, these four parentheses and that a squared are all times each other, so my final answer, I'm going to write it out all in purple, would be a squared times a minus b, a plus b, just taking those two down, a squared minus ab plus b squared, and then I'm not going to be able to fit that on that line. Let's see. We'll try. A squared plus ab minus b squared. There. It's really small. I want to be able to scan it, so I hope that pulls up when it scans. So, with that, that's 21 and 22. Now, 27. 27 is factored by grouping. And to fit the whole thing on here, let me zoom out, is you have this. So when you look at this, you have two groups. You have group 1 and you have group 2. So looking at the first three, I have a, c, b, and then I have an x squared, a y squared, and an x squared. Okay? Don't like any of those. This one, I have an a, b, c. Cool. I like that. It's a, b, c. Right order. Y squared, x squared. Oh, there's an x squared here, and there's a y squared here. I'm going to switch those two. Factor by grouping, just make your groups match. Otherwise, you really can't pull anything out. Now, I could pull a 2 out of everything here, and I could pull a not a 2 out of everything here. So right now where my groups are, really can't factor anything out. So, not going to do that. So on this first group, I'm going to switch things up. So this would be 12a x squared minus 18b x squared. Move the c x squared plus 24c x squared minus 10a y squared plus 15b y squared minus 20c y squared. Since I switched my order, everything's awesome. Once again, I'm going to draw my little groups. Okay, so out of this first group, I have a 12, an 18, and a 24, and I have an x squared. So the number that goes into 12, 18, 24 is 6. That's the biggest number, so I'm going to pull out a 6x squared. Okay. Left in that group is whatever's left over. So I have a 2a minus 3b plus 4c. Now in this group here, I have a 10, a 15, and a 20. So I'm going to pull out a 5, and then I'm going to pull out a y squared. So I'm going to go 5y squared, parentheses, and I'm going to write down what I got. Okay? So that gives me a negative 2a plus 3b minus 4a, and this is with a plus sign in between because it's two groups and I'm adding them together. So now I look at this and I'm like, oh, these parentheses are nearly the same, which is good because they should be really close to being the same, but now I see that the signs are different. This is all positive, negative, positive. This is negative, positive, negative. The back side is opposite of the front side, or the front side is opposite of the back side. I like my negatives to be on my second term, meaning the back side of the grouping. So what I should have done, and just because I didn't see it at the beginning doesn't mean anything's wrong, I should have pulled out a negative here. Now that I pull that negative out, what that means is this becomes a positive 2, this becomes a negative, and this becomes a positive. So now, I don't really like that, so I'm just going to erase this here. And I'm going to put a minus here. Erasable pen's awesome. So now that these two parenthesis sets match, they're the same factor. So this parenthesis set, the purple inside the red parentheses, is going to be pulled out in front. So that would be 2a minus 3b plus 4c times 6x squared minus 5y squared. Now, looking at this, this is a perfect squared, this is a perfect squared, but those 6 and that 5 are not. So then that's where I'm at with that answer. And I'm just going to check the answer. That's what I got. Yep. So I matched the book, so we're perfect. Now, these parentheses here do not matter the order. So the next two problems I'm going to do is 49 and then 50. 50 is another difference of squares, so I want to make sure we get some practice with it. This is also a difference of squares. So what squared gets you x to the 4th? X squared. What squared gets you 625? 25. Okay. So you have a grouping that's going to be a positive group, and you have a grouping that will be a negative group. That's the difference of squares. Literally, what's ever first, second, we pull respectively. So this would be x squared, 25, x squared, 25. Now, it looks like I should be done, but then I look here and I see, oh, this is a difference of squares again. So another way you can do it is x and x, 5 and 5, and then I know this is negative 25, so one of these have to be negative. So this parenthesis set is x minus 5 and x plus 5, and this set in the front does not change because that's the sum of squares, and there's no way to factor the sum of two perfect squares. All right, last but not least, let's do number 50. Number 50 is two perfect squares. This is x cubed, this is 8 and 8. One of these needs to be negative. So this first group is going to be x cubed minus 8. This second group is going to be x cubed plus 8. Now, it would be awesome if we were done right here because, like, math-wise, that'd be amazing, but we're not. So I look at this and I'm like, oh, that's x cubed. Oh, that's x cubed. So I need to look at sum of cubes and difference of cubes. Is there some number cubed that gets you 8? There is. It's 2. So then this is really 2 cubed and technically x cubed. And the same thing with over here. This would be x cubed plus 2 cubed. So because of that, I got to do the 4 parentheses. So I'm just going to write them out. So I'm just going to put them in the respective spots. So this is going to be x minus 2. I'm going to move this parenthesis over so I have a little bit more room here. So x squared plus 2 times x, 2x plus 4, because 2 squared is 4. Put that parenthesis here. X plus 2, x squared plus 2, oops, that should be a minus, I apologize, minus 2x plus 4. And that is the factor form of x to the 6 minus 64. Now, if you did it by perfect cubes, you would have a slightly different answer, which it still would be right as long as your math is right as you go through. Would it be the prettiest? No, but I'm not going to count you wrong if you do perfect cubes. If you did perfect cubes on this, I'm going to write that off to the side, just what it would look like. You would have done x squared cubed minus 4 cubed. And then you would work through, and you would actually work up with a part of this factoring down to here, but you might be off on one of these here. So, there you go. That is the homework problems that I wanted to walk through this weekend. I apologize that it's just getting done now, but snow days, computers, just, there you go.